Welcome to another episode of Telegeography Explains the Internet, the show that explores the business behind all of the ways humans stay connected around the world. I'm your host, as always, Greg Bryan from Telegeography, and today my guest is Phil Gervasi. He's the Director of Technical Evangelism at Kentik. What a great title, right? So, and you can hear it when you talk. He loves talking about this stuff. He gets really animated about it. So we had a great conversation. Our general topic for this episode was a sort of state of the union, if you will, on the corporate WAN in light of digital transformation, cloud, SD-WAN adoption, MPLS utilization, that kind of thing, which really brought us down a lot of different roads, but always with that common theme of where are we with how enterprises construct and utilize their WANs. So this included, the state of lift and shift into the cloud, the perseverance of MPLS, some real use cases of SD-WAN that have emerged, maybe apart from some of the earlier kind of suggestions on what SD-WAN would be good for. And of course, because it is with Kentik, we talked a lot about how these changes in the network have impacted visualization into network performance and security, and really how that needs to and is evolving to match these changes. So with that, I welcome you to this episode with Phil Gervasi from Kentik. Welcome to the show, Phil.
Thank you. Glad to be here.
Excellent. So as everybody who listens to the show knows, we always kind of start with a brief introduction of yourself and your company. Now, I've had a couple of your colleagues from Kentik on before, but it'd still be useful to know, precisely what you do at Kentik. So tell us a little bit about your background and what you're up to at Kentik.
Sure. So I was a network engineer, a traditional network engineer working in the trenches for years, for 15 years or so. And then I got into, design, architecture, working with customers directly to figure out problems. I love doing that, by the way, just keeping my hands, working in the trenches, like I was saying.
Out of the abstract, right?
I loved it. I really did. I enjoyed it. And then I had an opportunity to get into kind of a technical marketing role. My title is Technical Evangelism, which is really all about, like the word evangelism, bringing the good news to the world about what Kentik is all about, my current company. And as you said, Kentik has been on before. And what we're all about is network observability, which is kind of a new term. A lot of folks are familiar with the term observability. And then we added that prefix network for very specific reasons, which, we can get into a little bit. But ultimately, what I do at Kentik now is I go out and go on podcasts and write blog posts and do, demos to really show folks, kind of like Missouri, right? The show me state, to really show folks that, this is what we're all about here at Kentik. These are the problems that we could solve for you as a network engineer trying to keep the lights on and keep things working. And so that's what I've been doing for the past few years, and I love it. I really do. I mean, I get to do kind of a mixture of a lot of different things on the creative side and the technical side, figuring out demos. And what I didn't mention, I'll mention it now, is that I was a high school English teacher many years ago.
Oh, no kidding. All right. There's a lot of little twists and turns on your CV there. Yeah.
A lot of twists and turns, all unexpected twists and turns for the most part. But here we are. And, sometimes I look back and I regret and say, I wish I could have gotten to tech earlier or sooner and skipped this and skipped that. But my goodness, all those things really make up who you are, and the abilities and skills that kind of get you to where you are today. So.
Yeah, absolutely. It sounds like from your role, you have that ability to pull out of the trenches a little bit and maybe, take a look from the observation tower and kind of see what the market is doing in the broader sense. And that's why I thought it would be great to have you on to sort of discuss your views on what is going on with the WAN. Like, what should we be looking for? What are the delta? What's the delta really between kind of some of the expectations that people have had and what we're finding on the ground, sort of post-COVID 2022, how things are really shaking out. So just as a bit of quick background on that, when we were talking about this earlier, you had kind of sort of brought up the broad topic of talking about
Mhm.
SD-WAN, the impact of that on the demand for MPLS and changes to the network. So I looked at a little bit of our WAN manager survey data just to get a feel for that, and definitely we have seen MPLS utilization diminish over the years. We've been doing that study since 2018. It has gone down over that time. It's early days in my 2022 study, but it looks to be kind of flattening out, although DIA and broadband are still growing, of course.
Mhm.
But in other words, we're seeing that the sort of pullback of MPLS demand kind of stabilizing. And I've talked to a lot of end users who have mentioned that, maybe the promise of SD-WAN was at first something like an internet first kind of strategy, but we found that we really do need to maintain some amount of MPLS. But we have to have those local internet breakouts. We have to keep, having alternative transport available and that sort of thing. So, Phil, what's your take on this? What the people who were decrying the death of MPLS in the last few years,
Yeah.
were they wrong? Are they yet to be proven correct? What's your take there?
So, did SD-WAN ring the death knell for MPLS? And I don't think it has. And so I don't think that that means that it was a completely false narrative and that MPLS is here to stay and SD-WAN and it's all bogus. No, not at all. What I believe is, well, it's based on my experience, designing, installing, selling SD-WANs for a long time, right? And traditional routing as well. Don't get me wrong.
Right.
And what I saw over time is that customers' eyes lit up based on conversations not having to do with getting rid of their MPLS for a few different reasons. And so I saw that over time, right? So when did SD-WAN start to become a thing? 2015, 2016?
Yeah, exactly. 16, 17, as a commercially available product,
Right.
that with that name. Yeah.
But it didn't become ubiquitous out there in the field, actually deployed and in use until maybe just a few years ago.
A few years ago, even pushing it, a couple years ago, it would crest the sort of majority of enterprise networks I see anyway. Yeah.
Okay, there you go.
Yeah.
And so what that means to me is that I saw folks start off with the hypothetical, right? The narrative was we're going to save money by getting rid of your MPLS. We're going to, do all these things and it's going to be great. We're going to consolidate, go over the public internet, and it's going to sound beautiful. Your real-time protocols are going to work great. No problem. But then you started to deploy it. And then you started to see the reality of those iterations. And again, it's not like it was a false narrative. It's just that over time you got to see, when the rubber meets the road, how is this really going to operate, both from a network operations perspective and then also out in the world, dealing with ISPs and things like that. So what I saw were that a lot of large enterprises, especially that negotiate contracts with service providers because they have so many locations and that they have that weight, they weren't able to just ditch all their MPLS. They were under contract for years.
Right.
And sometimes they were able to negotiate such a low price that it actually made financial sense to keep it anyway. And so sometimes what I saw was that getting rid of MPLS was not either cost effective or not a technically, good choice. Keep it as a backup. Keep it as your primary, even because it's extremely low latency. Your sub millisecond latency and pings and all that kind of stuff. So it's a high quality circuit. And so the narrative started to change, and it wasn't getting rid of MPLS. It wasn't saving money, although that did happen from time to time when you had all these locations that were like my retail locations where I didn't have those contracts that lock in, so I could get rid of my MPLS and go DIA or just broadband. Fine, but generally speaking, that wasn't the case. And the conversation changed to how can I more easily get you connected to your cloud resources,
Right.
and or if you want to add CASBs in there and things like that, so it's cloud in the sense that it's something that's not on-prem. And how can I make your life easier as an engineer managing hundreds of sites? How, and I would say this to my customers, hello, Mr. Customer, how would you like to manage all 500 of your sites from one location with, one set of templates, with one set of certificates, and then deploy it all, that way with clicks of buttons, as opposed to logging into the CLI of 500 routers? And I'm telling you, engineers' eyes lit up and said, that is amazing. Can you do that for me? And that's kind of what became the conversation. There's a security story in there, of course, because you can deploy those certificates more easily. You can templatize your security processes and policies, so that's all true. But the network operations story and the cloud connectivity story is really what seemed to drive my conversations around SD-WAN for a few years. Now, MPLS, when it comes down to it, is still what runs the internet. I mean, you go to all the different service providers, it's BGP and MPLS in the backbone. So ultimately, no, MPLS is not going away. It's not being supplanted or replaced by SD-WAN, but SD-WAN is then just a way that we're augmenting network operations and augmenting networking today. I remember the SDN conversation. Remember that software-defined networking? That kind of evaporated.
I mean, it certainly for the enterprise customer, it never really became relevant. It ended up being something for the carriers to think about on their end and automation of provisioning and stuff like that. But yeah, I mean, anything that was relevant for the enterprise essentially from that became SD-WAN, I guess, so.
Yeah. Well, I mean, but that's the thing. This was kind of one of the first real manifestations, unmasked. So, as opposed to like open flow and things that a lot of enterprises didn't really use or experiment with. But SD-WAN, you started to talk about a centralized control plane and centralized policy and, being able to add some programmatic interfaces to managing your WAN infrastructure for a large enterprise, not necessarily some super hipster web scale company.
Right.
So I think that SD-WAN was one of those real palpable first manifestations of SDN in networking. And where that is today, I don't know. It's not necessarily a conversation about SDN, but I wanted to throw that in there because I think that there is a bigger story there about more than just MPLS and how now that we're in the throes of, replacing routers and training on, Viptela and Silver Peak and all these things and doing all these things, we're starting to see what the reality truly is, So.
Yeah. So I want to sort of maybe pull back a little bit in terms of the thinking for this, right? It was certainly, if we went back 5-6 years ago, like you were saying, when folks were talking about getting rid of MPLS, it was for cost. Then, like you said, you have some contract lock-ins or carriers saw the writing on the wall, at least shrunk the delta between MPLS and DIA, so, that I think happened, but it sort of has, diminished in comparison to the real impetus being getting away from centralized breakouts, right? So it really kind of ties all back to digital transformation, the promise of shifting all of your compute off-prem and all that kind of thing. How do you think that has played out in terms of where there was a big run up to move everything to the cloud? That was the impetus for having local instead of centralized breakouts. But where do enterprises find themselves with that transition now?
You mean just lifting and shifting everything into the cloud? Is that
has lift and shift lived up to his promise? Is it going to be the way that everything keeps moving?
Yeah. Well, no, I think if you want a straight answer, no. But it's really interesting that you bring that up because of the parallels here between the cloud narrative that has changed in very recent days and then the SD-WAN conversation narrative that has changed over the past few years, right? So the initial narrative around SD-WAN was save money by switching to all internet circuits and getting rid of MPLS. And then that changed because we saw the cost ramifications of doing that, all the different business and technical constraints that really started to emerge only after we began to implement and use the technology. Same thing with cloud. I remember when from the C-level, everything was, let's get rid of all our servers in our data center, shut it down, lift and shift it all our workloads, all our applications into the cloud, whatever cloud it happens to be. We will own nothing. We will pay for everything as a service. And then we'll all get massive Christmas bonuses. End of year bonuses will be flying.
Yeah.
That didn't really happen because what happened was over time, we started to see, right, as the technology began to be consumed more and in various different ways, sometimes ways we didn't expect, we start to see, oh, wait, this application, no matter what we do with it, doesn't really perform as well in the cloud, in whether it's AWS, Azure, GCP, whatever it happens to be. Whereas this application works great in the cloud. Okay, great. And then this application over here, my goodness, it's costing us so much to move data back and forth, and we're not really using it as a mission critical application. So does it make sense to put it in the cloud? Because I didn't expect that bill. So I'm going through this kind of top of mind, kind of walkthrough here, only to say that we are creating a new strategy and being more deliberate about how we look at this, right? It's not just lift and shift everything anymore. That narrative is crumbling and changing. I'm seeing blog posts and hearing podcasts that are discussing this very thing. Let's be smarter about what we are moving to the cloud. Let's look at our performance metrics and see where it makes sense to put this this very latency sensitive application, for example. I had healthcare customers where, and this was not necessarily a cloud discussion, it was an SD-WAN discussion. Healthcare customer in North America, in the U.S., that had one mission critical application in particular, healthcare, so hospitals, right? Operating rooms, people's lives, and there were very strict latency requirements on this MRI imaging software thing that they were using, right?
Absolutely,
they were experimenting with putting parts of this into GCP, didn't work well, and we were also discussing SD-WAN, and I could not promise them that they would get the same performance that they were getting on their MPLS. So they kept all their MPLS. Now, that is an SD-WAN conversation, but you can see the parallels with cloud.
Yeah, absolutely.
It plays right into the, what you mentioned about, is lift and shift really like an end-all, one-size-fits-all solution? The answer is no way, not anymore. Or maybe it never was, not anymore.
Yeah, that's the thing, is that so when I think back to years of doing this kind of WAN manager survey thing that we do at Telegeography, we certainly saw always that the biggest plurality of respondents about their sort of cloud strategy was that there's a mix of some stuff staying on-prem, some stuff moving to the cloud. I definitely do see what you're saying, though, that that there is, I think, more careful consideration to the application, to the data flow of the application now, because in the past, there were some respondents who were kind of along the lines of, there's some things I can't move off-prem even if I wanted to, because they're still stuck in like a mainframe that one guy knows how to operate, or something like that, right? So I think that part was always there. I do think we're seeing more of the kind of like, well, maybe this isn't something that belongs in the cloud. And this is getting a little bit far afield from where I was originally going with this, but I'm curious to hear your take on it. But is the push from the CSPs and from the neutral data center providers to move things further and further to the edge? Does that help with some of this problem, or do you think it really comes back to rethinking how the network and the cloud strategies work together?
Yeah, I have yet to see how that's going to play out with regard to cost. So I really don't know. I don't know about that. But for performance, yeah, I mean, this is how CDNs look at this, isn't it? Ultimately, how do I get the the resources as close to those who are consuming it as possible? And if it is in some region of AWS that's thousands of miles from where you're sitting, or if it's in a data center down the hall, the performance is going to be better when it's closer. So that's going to be a consideration here, because when we talk about both SD-WAN and then lifting and shifting to the cloud, it's not just about cost, it is about performance. And I think that it's only in recent days that we've had some of the visibility tools and methods and even thought processes. How do we do this? To be able to see, oh, this is what's going on. This is why my performance now stinks, because this application's in the cloud, or it's we're trying to put this new application out there that's built on containerized micro architectures or whatever, all that kind of stuff. And it's distributed in multiple clouds and on-prem. And how do you look at the performance to even know that it's because it's in the cloud that's the problem, or because of its geo that's the problem? So the visibility tools now, and of course, working at Kentik that's one of the things that I focus on very much. Visibility tools that we have and ability that we have, I think, allows us to make those better decisions.
And since you brought that up, I think one of the things that I wanted to ask you about was, okay, so in order to understand how things are performing in this new kind of network, obviously you need visibility into the network. What about the fact that the sourcing strategies have really changed for a lot of this? So again, looking at the kind of survey data that we have, it's much more common to use maybe a very small number of large providers for MPLS than it is for DIA or broadband, especially broadband. That's where we see folks much more willing to kind of branch out to the best in breed by country or something like that. When your network is all of a sudden kind of fractured by who owns it, where it's going, what kind of challenges does that present for visibility?
From a visibility perspective, therein lies many many challenges. What's
Right,
the
right.
plural of lie? Lay? I don't know. Yeah, a lot of
Weren't you
problems.
the English teacher?
I was,
That's
and that was one of
it.
my
Don't
hardest.
ask me. I don't know.
Yeah,
Yeah.
yeah, and I actually
Yeah.
taught traditional grammar, which is crazy.
Yeah.
But in any case, a lot of problems.
Yeah.
You mentioned the networks that you don't own. So you can
Hmm.
only get what the owners of those networks, right? The cloud provider, for example, will give you, whether those are, VPC flow logs or Google system logs. All right. So
Right.
you have that. Can you get more? And that's when you start to be creative. If you are running containers, you can start looking at things like eBPF, where you can look at kernel level visibility, which also gives you the ability to look at container networking, which is kind of a cool thing. Not many people are doing that right now. But it really you need to think of it in terms of having a diversity of visibility, a variety. Having all your eggs in one basket is going to result in an incomplete picture.
Hmm.
And so, using traditional methods like Flow and SNMP, packet captures where you need to troubleshoot, eBPF now, streaming if you're able to. Having that diversity is going to give you a more complete picture than otherwise, and that's what you need today, because you are looking at having, like, I guess you can call them like islands of visibility, right?
Hmm.
I can see a little bit about what's going on in my AWS region. Okay, that's cool. I can see a little bit there. I can see what's going on my LAN and in my private data center. I don't really know much about what's going on in between. Over here, I have these CASBs. I don't know what's exactly going on there, except this little bit of telemetry that they give me. So you have these islands or pockets. Maybe they're archipelagos.
Yeah, there you go. Yeah.
But you have these things. And
My
how do you
background is geography, so I can bring archipelago will work. That's again.
archipelago?
Yeah,
So you
yeah.
have these pockets of visibility. How do you understand how they relate to each other? And then another problem with this telemetry that we're looking at today. So these are the problems that we're facing with this with disparate network resources and distributed architectures.
Right.
Um, your data itself is very, very, very diverse, in the
Hmm.
sense that you have like millions of packets, right? So you have packets per second to look at. And over here, you have a percentage, right? 67% of your traffic is HTTPS. Well, that's a percentage. Here you have millions of packets per second. Here you have a percentage. Maybe you're also looking at temperature of your CPU,
Hmm.
on some bare metal servers that you own. These are all completely different things. So how do you compare them? How do you draw them all into a single platform so you can make some sort of conclusion about the big picture? This is what
Right.
observability is all about, by the way.
Hmm.
And that's where you start to get into the really cool stuff, where the data scientists begin to wax eloquent about AI and machine learning and scaling and normalization, and then how do you correlate disparate data? How do you get them on the
Hmm.
same scale? Very interesting. But those are the kind of problems that we face now when you have networks that you don't own, that you have overlays like SD-WAN, or maybe you're running some kind of VXLAN overlay in your data center, and also incorporating things like public cloud and everything in between.
Hmm.
So those, for as far as visibility are concerned, those are the problems that are plaguing actual network engineers trying to fix problems. Why is my application slow? And also security folks, like saying, where are we breaking encryption between this end to end flow here? Who owns the data that's in motion now, since some of it's on my network and some of it's on someone else? How do I ensure
Right.
compliance with whatever regulatory body? So it gets very tangled very quickly.
Yeah. So does that make it harder for someone like Kentik to present an end customer with the vaunted single pane of glass, right?
Yeah.
Or are you able to sort of resynthesize all those disparate data, like you said? Again, it might bring up a kind of philosophical problem of, okay, well, what do these data mean for the network user? Or maybe what do they mean for the security team on the IT infrastructure team? And are those different things sometimes? Are you able to kind of put that all together in the background, or do they need to bring something into that sort of visibility as well?
So when you say they, do you mean Kentik, or kind of the
No,
industry?
by they I would mean the end user. So
The end users, I
sorry,
see.
yeah, that
I see what you mean.
that in other words, to put it as, sort of really clearly, what a lot of end users want is to log on to something and have it tell them what's going on. Right?
Yeah.
Are we close to that?
We're getting closer.
Yeah.
Now, are we getting to the point where it's like the Enterprise, right? I'm a big Star Trek fan, and I can tell the computer, what is wrong? Like
Right.
Geordie LaForge talking to the Enterprise computer, right?
Yeah, well, I'm such a Star Trek nerd that it would be Majel Barrett who would answer, right?
Yeah, right.
Yeah.
And that's not quite where we are. We're not at that level of automation and programmability, and maybe that's like the pie in the sky of SDN, right? Of
Hmm.
of true
Hmm.
software defined networking. But where we are today. Oh, well, before I even get into it, I do want to make a point that a lot of these things are like security, application monitoring, application performance monitoring, network performance monitoring. They're all using the same data under the hood for the most part. There's
Hmm.
some variation, right? An APM tool is going to look at code level stuff more than an NPM tool would, but they're all looking at packets, flows, logs, VPC flow logs, all this different telemetry, but they're all looking at the same telemetry, but from a different perspective. So, is there some kind of an exfiltration going on? What are my endpoints? So, a security person is going to be concerned with that, but it's still TCP/IP and flows, right? And then a performance engineer or a network engineer concerned about a poorly performing network is looking at the same data from a different angle. So for us at Kentik and for any kind of mature and maturing visibility platform, it's really about collecting as much information as possible, right? Like
Right.
in Short Circuit, you had Johnny Five and more input, right?
Yeah.
That's, by the way, that came from Avi Friedman, the CEO and
Nice.
co-founder of Kentik. I did not come up with that, but I
I was going
love
to
it.
say only
True.
Gen X and above are going to get that reference, right?
Yeah, yeah. Oh,
Yeah.
I love that movie. But
Yeah.
in any case, that's the idea, is getting as much as you can, because the volume and then also the quality of the data is going to determine the outcome of your analysis.
Hmm.
So when you have a security engineer, application performance monitoring engineer, is that an engineer, an application person,
Yeah.
and,
Yeah.
and a network person, they're all looking at the same data from different angles. And so what we need to do behind the scenes is find those correlations, strong correlations as opposed to weak correlations, that can give some sort of insight. That's the hot term right now, actionable insight
Right.
into why an application is slow. So we want to get there very quickly. So I feel like what's going on with network visibility in general is more of like layering on a service layer for network operations. How can we make
Mm.
the life of an engineer better and easier? How do we get to that mean time to innocence faster? I'm
Meantime
going
to
to change that.
innocence.
Not
I've
mean
got to
time
use
to
that
innocence.
one for sure. Yeah.
Yeah, I'm going to say
Yeah.
meantime to resolution,
Yeah.
because this idea that I'm the network person and I'm just trying to prove my innocence and then I'm done and I leave the conference room, that's
Hmm.
baloney. That doesn't
Hmm.
happen anymore, or maybe it never did. I don't know. But I'm working with the security person and with the application person. We're all looking at the same data, just concerned with different things. And so all of that I just said poses a significant problem for those data scientists trying to figure out, how do we now make sure that those anomalies are accurate and not false positives, and how do we
Right.
identify when a security threat is truly occurring and it's not simply some kind of a seasonal pattern in traffic. How do we
Hmm.
tweak our algorithms and whatever statistical analysis we're using, so that way it's as accurate as possible? Because when it comes down to it, as an engineer, I need to be able to trust my system.
Hmm.
Is this thing correct? Is this insight accurate? And again, it applies across the board for application folks, network folks, security folks, all looking at that same data.
Right.
And what's interesting, something that we do at Kentik that I really think is cool, is we also take cost into account.
Ah.
How much do transit links cost? How much
Right.
does this path from this AS to this AS to this, how much is that actually costing you as a company? What does this peering relationship cost? So not only do we factor in all this variety of telemetry, we factor in things like cost and geolocation and threat feeds, because the old saying, garbage in, garbage out. You
Right.
want as high quality data as possible, and then as much as possible. The larger the data set, the more accurate your prediction can be, and that sort of thing. So as a security person, I'm looking at flows primarily, not necessarily looking at the flows, but the system is looking at flows primarily to identify patterns in traffic, patterns that correlate with known attack vectors. Oh, this is a DDoS attack. All right, fire off an alert. Well, a security person is they're excited about that. I have a
Right.
real time alert about DDoS. Came from flows. And then you have a network performance person looking at flows, being able to break down what's going on between these two ends of this conversation, this server in AWS, and then this branch location, and then break down maybe using packets to look at what the server response time is. Why exactly is that application slow? It's the same telemetry, but from a different angle, looking at performance. Mm-hmm. So it's difficult in the sense that there's a lot of it, and the data itself is very disparate. Like I said earlier, how you have percent over here and then packets per second over here. So that therein lies the difficulty.
Right.
But the idea, I think, is pretty straightforward. Make the life of a network engineer or security engineer, right? Make it better. How do we get to that resolution faster?
All right, so you were talking about some network problems, application problems, that kind of thing. How do you put together, from a visibility standpoint, the overlay and the underlay, and how well are those working together? Particularly, maybe there's some cases where you have very different vendors for that. Again, certainly a lot of folks have their overlay managed by their underlay providers and whatnot, but very often not the case. Does that present additional difficulties?
Yeah, that's part of this bigger picture of collecting as much telemetry as we can from as many sources as we can and ensuring its accuracy and its quality. But in the case of going back to SD-WAN, the beginning of our entire conversation, we have an overlay network and an underlay network. There's tunneling going on, IPsec, VXLAN possibly. That's a common protocol that's, common for some. There's proprietary things going on. And we need to collect that information as well, because there is an entire kind of second virtual network riding on top of the underlay, the infrastructure that we're not managing probably. And so that poses an issue. How do I correlate information from my underlay from my provider, whoever it happens to be, or multiple providers if I have a very large network, with my overlay network that I do manage? And if it is an overlay network that you do manage, is it proprietary in that you can't really get much information other than what you see on like your dashboard to manage your SD-WAN? See, so is there anything else I can get? So there are some problems that we're seeing with SD-WAN visibility that now that it's starting to mature and become so ubiquitous that folks are seeing, the actual problems of running an SD-WAN are manifesting themselves finally. And visibility is one of them.
But I thought all it did was solve problems.
All it did was solve problems. All your problems will be solved, and put a bow on it, and you're good, and you can just no more pager duty, none of that stuff. And we joke, but it is silly. It's the changing nature of technology, right? You fix one problem and it kind of opens the door to a new set of problems. But that's what we do as engineers. This is one of the reasons I love this field, is because we fix things and make it work. And in this case with visibility, the thing that we're trying to fix is how do we correlate, activity on my MPLS, which I don't own. I'm paying, lease lines and this and that, whatever. And then I have multiple providers connecting from my branch location to my data center, for example, in the Midwest US, so thousands of miles away. How do I correlate actual real-time activity with what's happening on my SD-WAN? So, having a platform to be able to consume telemetry from both of those sources and then to accurately represent something that's statistically interesting. But then here's a cool thing. Not just statistically interesting, but also like important to a real human engineer that's trying to fix a problem, right? An example is I used this at a recent event that I spoke at. I talked about having a 400 gig link in your data center. And it's humming along at 1 meg a day. It's like a back, I don't know, whatever, but it's rarely used.
Right.
And then one day you see, and you get an alert that it went from 1 meg on a 400 gig link to 100 megs. That's a statistically huge difference. So you're going to start getting all sorts of alerts that are firing because your system is
well within the capability of your 400 gig link.
So well within the capability that it means absolutely nothing with regard to application performance, because that's what we care about here. That's what the network is, right? It's just plumbing. It really means nothing. So what do I do? So you need to actually find a way to not only accurately identify those things that are statistically interesting, but then somehow add the subjective component to your algorithms or to your whatever you're doing in your system to then determine if that statistically interesting thing is actually relevant or important to a human being. That's hard. Yeah. So that's difficult. And so, collecting telemetry from sources that we don't own or manage, which is typical in an SD-WAN, and then being able to figure out, what do I alert on, so I don't just create the old alert fatigue that
Hmm.
that many of us have experienced. And ultimately, then what do? We just ignore the alerts, we turn them off, and then
Right,
what goes on?
exactly.
So
If everything is a problem, then nothing is, right?
there you go. Exactly. So some interesting stuff that's going on, and I think that part of the reason that we're able to make the progress that we're making lately is because the availability of storage and compute today is very different than it was, let's say, 15 years ago, 10 years
Hmm.
ago. Now it's much easier to really throw a lot of resources at having huge data sets and then being
Right.
able to crunch on it. There was a time when it was just the folks at MIT and Stanford that could do that. And now, you could spin up those resources in AWS and do a lot of that
Hmm.
yourself. So I think that's one of the reasons that we're making the progress that we're making in visibility and observability.
Yeah, no, that's really interesting because it gets into territory that's kind of beyond telecom. It's beyond the network. It's even beyond networking tools into just kind of general, AI and data science and sort of
Yep.
problems that people in kind of much more maybe sort of consumer oriented fields and
Mhm.
that sort of thing are dealing with the same kinds of things, but bringing that into our little world, which I find really fascinating because
But
there's
think about
so
it
much
this
yet to
way.
be done. Hmm.
You think about like some physicists or astrophysicists, right? That
Hmm.
are they're super cool because they get to work on like Hubble and discover
Right.
galaxies. Super nerds like me, right? Maybe they love Star Trek too. And they're collecting a ton of data from the James Webb and from Hubble and all these places, right? These physicists or astrophysicists, whatever they are, well, they also happen to know Python, and they also happen to
Right.
have huge databases, and they also happen to use columnar databases and pivot tables on Excel and GraphDB. Are they doing anything weird? No, they're using tools
Right.
to kind of solve their problem of how do we make sense of this data. So I don't know if it's really I don't agree that it's really like weird that we're applying it to networking. I
Hmm.
think it's
Hmm.
cool, and
Right.
I think it's long overdue because now we have this incredible amount of telemetry at our fingertips, and it's growing because we have new things like streaming and eBPF that haven't been traditionally used. But how do we work it to give us something useful, just like that, just like that astrophysicist writing a Python script in order to do
Right.
something with your data. They're not programmers, they're
Right.
still physicists.
Hmm.
So a network engineer working at whatever telecom provider, they're not necessarily programmers, they're just using another tool to make their job easier or better to find the
Yeah.
answers faster.
Yeah, no, that's a great point. I actually I tell my kids this all the time,
Yeah.
like that you need to learn to code no matter what you want to do, because it's just better to be doing your own code necessarily than my one son wants to be a nuclear engineer, for example. It's like, well, you don't need to learn coding for coding's sake. You need to learn coding for your physics sake, right? So, yeah.
Exactly. Yeah.
Yeah,
Yeah.
and certainly, I hear that from network engineers a lot, that that the sort of the next frontier in a sense is a buzzy word, but kind of the network as code and that sort
Yeah.
of thing, right? So
Yep.
yeah, absolutely, yeah. So then that brings us, I think, to the sort of conclusion here, which is, what does the WAN look like? Not necessarily from a visibility
Yeah.
standpoint, but from a conceptual standpoint in the next several years, you think?
Yeah. Well, one thing is for sure. We're gonna look at the WAN like we're looking at cloud, right? More strategically.
Hmm.
Does it always make sense to rip and replace all my traditional routers with SD-WAN boxes? And sometimes the answer is yes, sometimes no. And the answer may be no because I'm locked into contracts for the next 5 years.
Right.
And remember, if you're going to rip and replace your entire WAN with an SD-WAN, I mean, that's a project.
Right.
That doesn't happen in one weekend. That's a 3-year project
Yeah,
anyway.
I should say we've asked this question actually, and we got the vast majority of SD-WAN deployments took more than 1 year. So
Exactly.
and we're usually talking to people with pretty big networks, but still,
Mhm.
like yeah.
Yeah, and that's exactly right. And that's the reality of the implementation, like I was talking about earlier. It takes a long time to cut over site by site by site, especially if you
Hmm.
want to do it methodically without incurring a crazy amount of downtime. But we're going to look at the WAN and the cloud and all that in that way, more strategically,
Hmm.
from a cost perspective, from technical and business constraint perspective. But what does it look like from an actual thing? I do believe that we are going to see growth in SD-WAN. I mean, in
Hmm.
spite of what I just said, I wasn't really like when I worked for a very big national VAR. I wasn't really talking about routers that much. It was almost always SD-WAN.
Hmm.
When we were
Hmm.
talking about a WAN upgrade or upgrading branch sites or retail locations, it was usually SD-WAN.
Sure.
The only exceptions would be for when we were talking about huge big iron data center routers or some one off like that healthcare system. But generally speaking, I think we're going to see the continued growth of SD-WAN. Now, here's something that I want to throw out there, though. I've been thinking about recently. How is this going to look when you have maybe fewer branch offices and more
Hmm.
people working from home?
Hmm.
Do I really need to rip and replace my WAN with an SD-WAN right now? And how do CASBs play into this and other direct to cloud resources that I can
Right.
offer my work from home workforce? So there is a question mark there, and I don't know the answer because there is a whole return to office thing going on, and maybe it's a moot point.
Well, I'll be honest. I look into this a fair bit because it impacts kind of some of the things I do, like forecasting WAN revenue and stuff like that.
Hmm.
And the folks who sort of know about this, Pricewater, PwC, and
Yeah,
McKinsey and stuff like that, they're seeing pushback from the manager class, but it all is going to come down to, I think, employee clout, because nobody wants to go 5 days a week back, right? So,
yeah, yeah,
and we so we've seen it kind of, I think, maybe stabilize at where it is kind of now, and I hear that from some of the WAN managers I've talked to, who are all mostly working from home, as are most IT back office kind of people, right? So I think they're preparing for that. So
yeah,
however it really does end up, that's the way the WAN manager community is thinking about the future of the WAN right now, anyway. So
yeah. Which presupposes then that there is going to be a continued decrease of the traditional perimeter, which we've seen
right,
for years already
right.
anyway. But even more so, I think that's going to just expedite that process. And it's going to continue to push services to the edge. To when
Hmm.
I say the edge, I mean maybe to the endpoint itself.
Right.
What can I do on the endpoint that I used to do at the branch level because there
Hmm.
is no branch. So yeah, I think we're going to see some. I'm already starting to see a lot of those changes. Instead of the network security component at the branch office, everything is just deployed on the endpoint now.
That's a really important point, because, like you said, certainly before COVID, it was moving in that direction
Mhm.
anyway. We all became, but now you have the situation where, maybe, in some lines of work, right? Obviously, this varies a lot by vertical, but there's going to be folks where the vast majority of your end users aren't near a device, a router of any kind that you own, right? So everything that you do has to be done on their device
Yeah,
itself, right? So it's all software based and that kind of thing, right? So,
yeah, yeah. And therein lies the problem that we mentioned earlier. How do you capture telemetry from that,
right,
considering they are running on a network that you don't own at their house, and then with some provider that you don't have a relationship with as
right.
the network manager, you don't have a relationship with their residential provider.
Hmm.
And then how do you ensure application delivery is top notch, top quality when it's again to over some network you don't own to some house somewhere.
Hmm.
And so there's a lot of and the visibility portion too. How do you capture that and correlate that with things going on in the day? It's tough, but that is where we are, and I really am interested in seeing how we are using a lot of technology from other fields like data
Right.
science, like you mentioned, to solve these things. So
Yeah. Yeah. Awesome. Well, that's kind of what keeps it fun, right? Is
yeah,
that it is never static, right? So,
never
um,
static.
uh, yeah.
I never
Um,
thought I would be searching on YouTube for machine learning courses. Like Stanford has free machine learning courses.
yeah.
That's what I'm doing a lot lately, and it's crazy. I never thought I'd be doing that. I
Hmm.
used to be studying BGP stuff, and now I'm trying to figure out how this algorithm works. And I don't know. It's crazy.
Yeah. Well, that's that back to sort of like utilizing the tools from all other fields, like in a way that benefits your field, I think is
Mhm.
the key, right? So, Excellent. All right. Well, Phil, this was super interesting. I think this is one where I might go back and listen to it again and try to get nailed down on some of the visibility stuff, because I think there's so much that will be happening there in the next few years. So,
Oh yeah, for sure.
yeah. So thanks so much for joining us. Let's definitely catch up and see how all of this emerges.
Great. Look forward to it.
Excellent. All right. Cheers. Thanks for listening. Telegeography Explains the Internet comes from the experts here at Telegeography. It's edited and produced by Jane Miller, and it's hosted by me, Greg Bryan. And I also wrote that theme song you're listening to right now. To learn more about our data, jump over to telegeography.com, and we'll see you on the internet.